Hi, everyone. Let's take a look at resultant vector today. Let's review some basics. Any vector, we can call it a vector A, or we sometimes call it a vector R, or maybe uppercase R, or if it's a force, we can call it a vector F. But anyway, those are the very traditional way of labeling the vector. Remember, not only we have a letter, but also have an arrow on the top, which means not only it has the magnitude, but also has the direction of it. Any vector, it has a tail, which is a starting point, also a head, which is where the direction goes. And the head, we also call it the tip at times. If we have two vectors or more, we can add them together. And the total value of the vector, we call it a resultant vector. The resultant vector, let's say vector R, could be equal to RA, which is a vector A, plus RB, which is a vector B. Or if we have a force, the resultant vector could be equal to force A plus force B. Or we can have, let's say we have force 1 and force 2, and we add them together, it is called the resultant vector. If we have more, let's assume that we have three forces, F1 plus F2 plus F3. And then now we add them together. The end result here is called the resultant vector. This is also kind of a definition of the resultant vector. It is the addition of all the vectors that you're interested in, adding them together. Something important about resultant vector, we cannot just add its magnitude together. For example, if we have a force, let's assume that force number 1, okay, going up and equal to 10 Newton. Okay, so the first force, we have the magnitude 10 Newton and the direction going up. Now we have a second force, let's assume that go completely in opposite direction, which is 180 degree. Let's label it as a force 2. And we assume it's equal to 10 Newton again. So now we have the second vector force. Magnitude equal to 10 Newton, direction going completely opposite direction of the F1. Based on your experiences, you know that the total force in this case would be equal to 0. Because you're pulling, let's assume that you have a box here. You're pulling the box upward 10 Newton, opposite direction, another 10 Newton, and those two forces, they kind of cancel out with each other. That's why the total force is equal to 0. It is very well balanced. We also call it equilibrium. But in this example, F1, the magnitude equal to 10 Newton. When we use the absolute value sign, it stands for the magnitude of a vector. And F2 in this case, the magnitude is also equal to 10 Newton. If you assume that the resultant vector, which is addition of two vectors, equal to F1 plus F2, the magnitude simply, then it should equal to 10 Newton. But in reality, this is not the case. Important lesson about vectors. Never add the magnitude together if you're looking for the resultant vector, unless those two vectors, they are in the same direction. Otherwise, we will need to follow some rules. And we will give an example a little bit later to explain how can we find out the value and the direction of the resultant vector. By now, the conclusion is for vectors, if we are looking for resultant vector, we cannot just add the numbers together. We have to take consideration of the direction in our calculations. There are many different ways for us to find out the resultant vector. If you learn the calculus, you can do the loss of cosine and the loss of sine to find out its magnitude and its direction. If you have a graphing paper, you can also draw resultant vector based on the two vectors or more vectors you're having. We can also use the tip-to-tail method to find the general magnitude and direction of the resultant vector. Additionally, we may use a basic calculation by components of a vector to find out the resultant vector with its magnitude and direction. Now I am going to introduce you one of the methods called the tip to tail. By saying tip to tail, remember that any vector, we have a tail and we have a head. And again, the head is also called tip. Let's assume that we have two vectors. Let's call it F1 and F2. Tip to tail, which means that we need to connect the tail of the second vector to the tip of the first vector. So let's look for the second vector, F2. The tail is right here. And now we need to connect this tail to the tip of the first vector. Okay, so first vector right now is kind of far away from here, but remember the property of the vectors, we can move it in parallel to self and the value does not change. So let's move this vector in parallel to the self and come to here. And this is a direction, okay, going downward, and here's origin 0, and here is origin 0, which is the tail of it. So this is the F1 that we were having. F1 first vector and F2 the second vector. Now look at here. So we have the tip of the first vector is connected to the tail of the second vector. This is called the tip to tail because the tip and the tail, they are connected. Let's call it RF, resultant vector. Would be equal to the value that is connected from the tail of the one vector to the tip of the second vector, this direction. So this would be the resultant vector. This is an example of the tip to tail. In other words, when we add F1 and F2 together, the resultant vector would be as labeled here. Now let's see another example. We'll call it F1 and F2 again, with the two vectors. We are looking for the resultant vector, which will be equal to F1 plus F2. Remember, it has a directions, so it's not just simply add the numbers. Now, we're looking for a resultant vector, which is the addition of both of them. Based on the rule of tip to tail, we need to connect those two vectors, tip by tail. So what we can do is we can move either one of them. Let's assume that we move F2. Okay, so remember, we can move the vector in parallel to self, then its value does not change. And in order to connect those two vectors to tail, we need to connect the tail to the tip or tip to the tail. So apparently, if I move this one all the way up to here, that will be tail to tail connection, which is not correct. So we need to continue move it all the way to here, horizontal. This is the F2 that we moved over from here to here. F2 initially is here. F2 right now is, they are parallel with each other. Magnitude and the direction does not change, which means this F2 was successfully moved up to there. And now let's look at the new combination of the F1 and F2. They are connected tip to tail here. It met the rule of tip to tail. So the resultant vector will be always equal to the vector that is connected from the tail to the tip. Okay, so we connect them together, and this will be the direction of the new resultant vector. In other words, the combination of the vector F1 and F2 will be equivalent with the new vector, resultant vector RF here. Let's come to the special case. What if right now I have two vectors? One of them goes to horizontally. Here is a tail. Let's call it X. And this one going up vertically, let's call it the Y vector. Okay. And now look at this case. Here is 90 degrees, which is a right triangle. And the tip of the first vector is connected to the tail of the second vector. It also meets the rule of tip to tail. In other words, the combination of the vector X plus vector B would be equal to the resultant vector. And based on tip to tail, the resultant vector will be equal to the new vector that is connected from the tail to the tip of those two different vectors. And this can be labeled as R. In other words, the combination of vector X and vector Y is equivalent with the vector of R. Now, if you look at this right triangle, does it seem familiar to you? In our previous video, we talked about components of vectors. In a right triangle, we have the hypotenuse and we have two sides. And this is the angle that we were talking about, which is theta. And we discussed, okay, the horizontal part, we call the X components. Vertical part, we call the Y components. And then the X components based on the hypotenuse and the angle will be equal to R multiplying cosine theta, because this is adjacent sides. And the value of a Y would be equal to R multiplying sine theta, because the side is in opposite to the angle. Let's take a look at the Pythagorean theorem. Remember the Pythagorean theorem, we know that the square of one side of the right triangle plus the square of the other side of the right triangle will be always equal to the square of the hypotenuse. Let's verify if this components and tip to tail theory meets our assumptions. Okay, so X is R cosine theta, and we square it. Y is R sine theta, and we square it. And now it will be R square multiply cosine theta square. And the second part will be R square and sine theta square. We have the common factor R, which means we can take it out. So it will be equal to R square and the cosine theta square plus sine theta square. And cosine square plus sine square will be equal to 1. We have the total value equal to R square, which verifies the equal sign here. So X squared plus y squared equal to R squared, which is exactly how the Pythagorean theorem works. By looking at the big pictures here, the components of the vector that we discussed last time, telling us how can we find out the value of the components for any vector by building a right triangle. But based on the tip to tail rule, we also figured out the resultant vector basically is a combination of the two vectors based on the sides of this right triangle. As a summary, any vector can be always decomposed into the X components and the Y components. And we can always use the trig function to find out its value if we know the magnitude of the vector and the direction, which is the angle of the vector is. Now let's take a real example with numbers. Assume that we have two vectors. Both of them have magnitude and the direction to go with it. We are looking for the resultant vector, which is a combination of vector F1 and F2 together. Okay, remember, there are different ways we can do the calculation, and the two methods we explained earlier, including tip to tail and by using the components of vector. So first of all, let's take a look at the tip to tail. So let's draw out F1 and F2. So F1, 50 degree, and going to the east and going to the south. So that's why it's coming down in this direction. And it is 150 Newton, that's F1. Okay, with an arrow. Now F2, it's north of west. So west going to right and north going up. And we're looking for 80 degrees. So it will look like this. So this will be the F2, the second vector with 200 Newton. Now we have both vectors. With the tip to tail, we need to connect those two vectors by the tip and the tail. Right now, if you look at the connection, it's tail by tail, which does not work. So what can we do? Remember again, any vector can be moved in parallel to itself and its value does not change. It's up to you if you would like to move F2 or F1 at this point. And let's assume we move F2. Okay, so in parallel to self somewhere, and we need to get it connected to the tip of the first vector. So it will be something like this. Okay, now take a look at the new F2 here. Okay, first of all, the magnitude, okay, it's about similar. I'm so sorry. I should have used the graphing paper so that way it will be exact. But right now it's approximately. Okay, so the magnitude is about the same and direction also it's about the same. And it's being moved like a parallel to self. So the value does not change. So now look again, F1, the tip, is connected to the tail of the F2. So that meets the rule of tip to tail. It tells us the resultant vector will be connecting from the tail of the first vector to the tip of the second vector. So this is going to be the resultant vector F that we are looking for. So the magnitude will be this big and the direction will be going to this direction. And we need to figure out what is the angle theta here. So this is by tip to tail. Next step, we are going to use a real number to figure out exactly how big the vector is and what is the direction of this vector. And I'm going to move this entire diagram to the corner here, so that way we have more space to work with our calculations. Now the tip to tail resultant vector is being moved over. We have F1, 50 degree, 150 Newton, and F2, which is 80 degree, north of west, 200 Newton. And this is the resultant vector that we are looking for in order to figure out its magnitude and its direction. Okay, now let's do the calculation by using components of vectors. F1, so let's do one by one. First of all, we need to draw out the coordinate system. Okay, and this is our origin and the horizontal x and the vertical y. We are looking for source of east 50 degrees. So source again going downward and east going right. And it will be in the fourth quadrant, 50 degree. Okay, so this is how F1 will look like. 50 degree here. In order to find x and y components, we always draw a vertical line from the tip or head of the vector towards to the x-axis. So in this case, x-axis is horizontally, it's on the top. So we're going to draw a vertical line going up. Okay, here is 90 degree. And this vertical part, we call it y component. In this case, it's F1 y component. And this horizontal part, we will name it F1 x component. Now, based on the trig function, F1x will be always equal to F1 multiply cosine theta. And we know the value of F1 equal to 150 Newton. And the angle, we know that's equal to 50 degrees. Now use your calculator, we find out the value equal to 96.42 Newton. That is the x component in this right triangle. The y component is called F1 y component and would be equal to F1 multiply sine 50 degree, because the y component, we're talking about the opposite side, which is sine function. And again, plug your numbers in, F1 magnitude 150 degree and multiply sine 50 degree. Now, by using your calculator, we find out the value equal to 114.91 Newton. Now, one thing is very important, which is the direction. Let's take a look at F1. F1, here is the origin, right? F1 going to the east, so it is a positive. Now, F1y, you're going to source, going down, so which means it's negative. So we need to add a negative sign onto it. That is the x and y components for F1. Next, F2. F2 is 200 Newton, 80 degree north of west. So north going up and west going left, 80 degrees. So it's like this. Okay, this is 80 degree north of west. And F2, magnitude 200 Newton. Again, in order to build the right triangle, we will need to draw a vertical line from the tip of the vector towards to the x coordinate. So x coordinate is horizontal here, and it's below the head, which means we draw a vertical line down. And again, here is a 90 degrees, the right triangle that we discussed when we can apply trig function into it. Now the horizontal components, we call it F2x, and the vertical component, we call it F2y. Based on the components of the vector, we know that F2x value would be equal to F2, which is the hypotenuse, multiplying the cosine theta, because cosine theta relates the adjacent side. Now plug the numbers in, 200 Newton. And cosine 80 degree. Now plug numbers into your calculator and we find out the value equal to 34.73 Newton. Next, F2y, which is y component of the second vector, would be equal to F2 multiply sine theta based on the components of the vector. So we are looking at F2y, the opposite side of the right triangle. By using the trig function and plug numbers in, sine angle is 80 degree. We do the calculation, we find out it's equal to 196.96 Newton. Now let's check the direction. Okay, so F2x is going to the left because it's west. So it's supposed to be negative. We need to add the negative sign. Now F2y is going up, right? Okay, because it's going to the north. So that's why it remains to be positive. So now we've got the magnitude and the direction of all the components for both vector F1 and F2. Next step, we need to add all the x components together. The total components of the x direction for this force, we label it as Fx, would be equal to the first vector x component plus the second vector x component. And we know the value of them. First one equal to 96.42 Newton. And the second one is negative 34.73 Newton. Use your calculator, we find out the value 61.69 Newton. Similar thing with y direction. Fy would be equal to F1y plus F2y. And F1y equal to negative 114.91 Newton. F2y equal to positive 196.96 Newton. Now use the calculator, we find out the value equal to 82.05 Newton. We're getting very close to the final results. In x direction, Fx equal to 61.69 is a positive value, x direction, which means horizontal. And it's positive, so that will be the Fx. Now Fy is also a positive number and going vertical. Again, y direction, which means it's vertical. X direction, which means it's horizontal. Now we have two vectors, Fx going horizontally and Fy going vertically, and they are connected tip to tail. Tip to tail. So the resultant vector based on the rule of tip to tail will be equal to, from the tail of the first one connected to the tip of the second vector. So this is going to be the resultant vector that we are looking for. And here again must be the 90 degree. In this case, because x component is horizontal and y component is vertical. Now by looking at this right triangle, we have two sides, Fx and Fy, and we're looking for the hypotenuse. Apparently, we can use the Pythagorean theorem to do the calculation. The resultant vector, the magnitude will be equal to square root of x component plus square of the y components. Now let's plug the number into it. Fx 61.69 Newton and Fy is 82.05 Newton. Now plug the numbers in calculator. We do the calculation, find out equal to 102.7 Newton. Next part for the direction. So direction, which is the angle that we are looking for. And this angle will be always equal to inverse tangent. In our previous video, we talked about the tangent sign and inverse, which means we're looking for the angle of it or the direction of it. And it will be always the y component divided by the x component. And then I'll plug the numbers into the equation here. Y component and the x component. And the units will be canceled out with each other. Now we do the calculation by using a calculator, we find out equal to 53.1 degree. Now the conclusion is the resultant vector, the magnitude will be equal to 102.7 Newton, which means it's the magnitude of this much. And the direction will be 53.1 degree, which is 53.1 degree, which goes to the north of east. If you wanted to write down the description of the resultant vector in this case, which means magnitude 1.2.7 Newton, and the direction 53.1 degree north of east. That will be our conclusion. If we look at the results here to compare with the tip-to-tail we had earlier, now earlier the resultant vector from the tip-to-tail is this much. So it's kind of similar with the magnitude and also the direction, which is located in the first quadrant of the coordinate system. The major difference is the tip-to-tail does not really tell us the magnitude or the degree of the angle of it. It's more of a general size of the resultant vector. With the calculation we're doing based on the components of vectors, we are able to do the calculation and find out the exact value of how big it is, find out the magnitude, and also the direction, find out the angle. So we are able to check off everything that we're interested about the resultant vector. As a summary, in order to find out the resultant vector, in this case, we only have two of them. If we have more, we can continue doing the similar thing, just to find out the x, y component for every single vector. And then we add all the x components together, add all the y components together, and you can use the Pythagorean theorem to find out the resultant vector magnitude and the direction, which is the angle of it. In a case, we have two vectors. The first step, we need to establish the right triangle that we're interested in. By drawing the vector, then you draw a vertical line and find out where x component is, where y component is. The second step is to do the calculation. For every single vector, find out what's the x component, what is the value of the y component by using the trig function. Then step number 3 is to find out what is the resultant vector, which means all the x components needs to be added together in x direction. All the y components needs to be added together for y direction. One important thing to keep in mind is to double check the sign, whether it's positive or negative. That will make a big difference for your results. Then the very last step is by using the right triangle Pythagorean theorem to find out what is the value of the hypotenuse. In this case, will be the resultant vector. And finally, find out the angle or the direction of the resultant vector. By following those 4 steps, 1, 2, and 3, 4, you should be able to resolve all the problems with resultant vector. All right, I hope this is helpful to you. If you have questions, reach out to me. Have a nice day.